All right. So for the next 40 minutes, I think we are going to talk about hosting a Spring Boot app on Kubernetes and what it takes, and what are things involved while we move them or port them to Kubernetes. Just an introduction, my name is Boskey Savla, and I'm a technical product line marketing manager working in the modern apps business unit at VMware. I have been, in my past life, I've started off as a Linux system admin, went into DevOps and solution engineering, and then finally got into the technical marketing space or advocacy space at VMware. So the agenda for this next 40 hours will be split into two sections. The first 20 minutes is mostly where I'm going to talk about what is Kubernetes, why does it matter, and what are some of the cool things that you could do with that. And then in the next 20 minutes, I'm going to take a sample application in Spring Boot and then walk through the different steps that are needed to port that to Kubernetes. So why Kubernetes, right? I think we are hearing this more and more, and the fundamental question to answer or to ask ourselves is why moving to Kubernetes? Why should we move to Kubernetes, and what makes it so worthwhile to look at? The way I think about Kubernetes is it's a part of a natural evolution. You heard Mike Heckler talk about how everything a business wants to do starts with that software process or that change within that software process, or implementing or testing, new products and features. And what is very critical is the time it takes from a build to a production, pipes, the cycle to run through everything, to develop test, to develop code, and then finally put that in production and then run it there. So for me, the way I look at it, constantly the way IT teams or the way development teams have been working together, we have done a lot of changes in our processes over a period of years to make the software development lifecycle as short as possible, as iterative as possible, and as agile as possible. Now, if you look at the application development landscape itself, there are these two different groups that I feel like, DevOps kind of merges those two practices at some point, like the earlier guest was mentioning. But from an evolution perspective, we really didn't have those things to begin with. Like, imagine writing code in C, and then Java came along and it abstracted away some of the things that C was doing so that we could have portable applications. And then we have Spring, and then now Spring Boot, that make that process of writing code more and more efficient, more and more better. Probably something that takes 10 or 15 minutes to write in Spring Boot today probably took like a couple of hours with C. And then, the life cycle of creating software and running it is as long as your software development processes are. But at the same time, how your infrastructure rolls with these changes also matter a lot. So if you have figured out everything within your, if you have created pipelines, if you have created code that automatically builds provisions and things like that, but if your infrastructure is lagging or if it doesn't respond to dynamic changes, it doesn't really matter, because that's going to slow down the entire process. And we have evolved a ton in that sense as well, like, from left to right. By adding more and more abstraction layers of the infrastructure, we have made infrastructure kind of, similar to writing code, right? You can modify things with code and, model your infrastructure the way your application requirements are. And this started off with, very, very fundamental, like, I don't want to go all the way back to mainframes, but like, we had physical servers, that we brought in virtualization, which gave us the ability to spin things up and made things a little bit more portable, along with cloud, where you're pushing applications through an API, and there's a lot more elasticity. And then to a lot more newer objects like containers, which take that portability equation even higher up, where it doesn't really matter what operating system you're running. The containers itself are or can move around, doesn't irrespective of the OS. And then the final or the ultimate, I feel like the best of both worlds is where we have a platform as a service, where you have a platform that takes code, understands its dependencies, scales it, builds it, provisions it, does all the networking needed to expose that application to the world, and automatically load balances it, right? That's the best case scenario. Now, today, however, we are going to step back a little bit and look at Kubernetes. And why is that the case? I mean, if PaaS is our ultimate goal, then why are we talking about Kubernetes? A couple of things come to mind. Although Kubernetes is a lower level abstraction than PaaS, it's still pretty high if you think about the way infrastructure is created. And when you have a completely integrated stack like PaaS, rolling out new technologies or integrating your code with a new set of technology, let's say I want to monitor my application using Wavefront, or I want to use something else, that usually means that your PaaS stack has to be integrated with that new technology, or it has to be validated, tested, and it can take some time. Whereas Kubernetes, on the other hand, it goes one level lower in that abstraction, but then it has the same functions in the sense that it can scale your app, it can build it, it can run it, it can network it effectively and things like that, with some declarative files. So I feel like it's a good state for a lot of companies, a lot of organizations. That's an ideal scenario too. And sometimes we see people have PaaS and Kubernetes side by side, depending upon their workload types. So now getting a little bit into Kubernetes, why it matters, if you think about how, even if you're writing a Spring Boot app today, let's say you're writing an app that has to talk to a database server, right? And if you want to bring up, if you want to start writing code for it or build that app, you're going to define your application through Spring Boot, your dependencies, etc. But then you'll have to bring up a MySQL server somewhere so that you can run a build, test everything works. Now, even to bring that MySQL server, you'll have to then figure out, whether I bring in a virtual machine, where do I put my MySQL server? Do I run it in a Docker host? There are multiple options, and it's not always very easy to map things. At the same time, once you have built your application, you want to create a test environment where you don't have your local settings just to validate how your application is performing when it gets packaged and shipped out, right? Also, from a deployment perspective, right, we want to have an application that's elastic. Even if the infrastructure is elastic enough, like if it's running on a cloud, we want the app itself to be elastic there. That way, it can scale out or scale in or scale up and down depending upon a certain kind of workload and capabilities like that. At the same time, as a developer, I really want to, sometimes really if I'm working on a front end or something, I want to see some validations. And this is a classic example where, as Mr. Heckler said, like, you want to run some tests, whether you're running an A/B test or whatever other kind of test you want to run. You want to push for, a different version of your application just to validate your customers' responses. And you want to be able to have two versions of the same app at the same time, and yet, magically send 80% traffic here and 20% there or something like that. And all these capabilities, a lot of times, the ideal world scenario is you don't want to talk to IT to build a ticket and say, okay, give me a load balancer now, or give me a new deployment, or roll this deployment out into production, or things like that, right? Or at the same time, even if you're working in a cloud, like you don't want to understand the concept and the constructs of that cloud provider or data center, wherever you're running those applications. Like if you're running on AWS, it's not necessary to understand EC2, the ELBs, the S3 buckets, and things like that AWS has. So my focus as a developer is my application. It's not looking at infrastructure. It's not understanding infrastructure. It's not necessarily talking to IT at a ticket-based approach if I have to be agile. So that is where I think Kubernetes shines the most. That is where Kubernetes comes across as a really great platform to do something similar. Now, let's take a deeper look at what Kubernetes is, right? There is a book, textbook definition of Kubernetes that it orchestrates containers, but I don't want to talk about the textbook definition right now. To me, when I look at Kubernetes, there are 4 fundamental things that it does, right? 1, it is abstracting away infrastructure. 2, it is automating infrastructure for you. 3, it is maintaining state. And 4, it has a service-oriented architecture inherently, and I'll get to what that really means. Now, 1, when I say it's abstracting infrastructure, what I really mean is it is a single platform that sits in front of a given infrastructure. It could be a cloud, it could be on-prem, it could be anything, but it provides you a northbound API that you can easily talk to or understand with certain object models. I think there was a question like, why can't Terraform use the same language to provision to all kind of cloud providers? I think if the Terraform did that, it would basically be Kubernetes. So Kubernetes is basically an abstraction layer that sits in front of your infrastructure. At the south end, it talks to all different cloud providers. And at the north end, you talk to Kubernetes through an API defining objects and dependencies for your application. So the counter effect of that is, as a dev team, I don't really care about what infrastructure is running in the back end. I'm just talking to a single API. I don't know how networking is set up. I don't know how storage is set up. I don't know what cloud provider is in the back end. I just know I have a Kubernetes cluster that magically is going to automate everything in the back end for me. It automates infrastructure, which is the second point. And what do I mean by that? So if you think about, let's say you define an application workload, you create a Spring Boot app, you put it in a container, you tell Kubernetes to run it, and then you tell, okay, one of my apps also needs to talk to a SQL server that needs a persistent volume or things like that. You just declare that in a file and you give that to Kubernetes, and then Kubernetes will go, it will talk to the storage backend and create a 50 gigabyte or how much ever you specified volume drive, and automatically map that to the MySQL pod or container. So that is what I mean by automation. It takes the state or the application dependency that you define and then automates the infrastructure to make that happen. Now, the third and the most critical feature I feel of Kubernetes is the way it maintains states, or it's very declarative in the sense that once you provide Kubernetes with your application binaries packaged in a container, along with how you want that application to run, it will make sure that the app is always running in that same state. If you say, here is my container, run 5 copies of it, Kubernetes will always run 5 copies of it. If one of the container dies for some reason, it will spin up a new one. This applies to not just pods running or containers running, it applies to virtually every object that Kubernetes manages, all the way from storage, networking, and things like that. So what that really means for me as a developer is it brings in a lot of resiliency into the platform, wherein I don't have to worry about what happens if the networking backend fails. How do I architect my application to work around it, right? So all of that availability issues are handled a little bit better with Kubernetes. And fourth and final, it has a service-oriented architecture. And what that means is, let's say, again, going back to the same example, like you have a jar file that's put in a container, and that application needs to talk to a MySQL server. Now, traditionally, the way we would go about it is we would build the app, and then we would pass some parameters, things like IP addresses and ports and things like that, to that particular Java app, and then things can be configured ahead. With Kubernetes, everything that you deploy has a label associated with it, and it has the capability of reverse looking up that label. So what that lets you do is when you run an application in Kubernetes, all you have to do is tell the name of the app that it needs to connect to. Kubernetes will go fetch the IP address and it will route things automatically. So you don't necessarily have to deal with IP addressing mechanisms, none of that, right? All you are dealing with is service APIs, and that you could define whatever those could be, right? So that is a big plus for me. This is also something that sorts out the entire networking stack and how things get routed, how ingress works, how load balancing works. A lot of that in Kubernetes has to do with the labels that every object gets, and then the way Kubernetes reverse looks up those objects or matches those objects to create appropriate routes. So I know there's a question. I'm just going to pause and yeah, there is a demo. So I think that's the question. Now, how is Kubernetes doing that, right? So Kubernetes is the way because Kubernetes is automating everything, it has to know how to talk to different infrastructure providers. So if you look at the upstream Kubernetes project, it has multiple different three major provider types or plugin types. One is the cloud or the compute provider, one is the network provider, and one is the storage provider. And if you look at those plugins basically define how Kubernetes interacts with these different providers. So if you look at the upstream project, you will see a lot of vendors making sure that their platforms are integrated with Kubernetes. And when a plugin is registered for example, an AWS cloud provider, Kubernetes understands how to talk to that AWS cloud provider, what APIs to use, etc. And in the backend, that is how it is automating in the the southbound APIs for Kubernetes. That is how it is managing a lot of these automation. Now, I mentioned that Kubernetes is automating things for us, and however, we need to define or we need to tell Kubernetes what are our requirements for a particular application. So if you think about it, a lot of applications have very standard, ways of defining things, right? Or a list of things, right, that's needed. One, we need a binary in which we can ship our application and that can be deployed effectively. Once application has been deployed, we need to pass some environment configurations. So for example, if you have to, talk to two different applications, you need to understand how to talk to them or what port to communicate on and things like that. Or if there are certain secrets to be passed around, like username, passwords, or any sensitive data, we need some way to figure out how environment configurations work. And then, of course, you have to define some resource requirements like CPU, memory, storage, etc. How many instances of that particular application you want to run, how you want to load balance, or how you want to provide ingress services to some of the application workloads that are running. How do we define security and things like that? So what Kubernetes does is it has a standard way of looking at all these different application requirements through its object resource model. So for example, when you want to deploy an application binary, Kubernetes calls it a pod or a deployment type. It's a logical object within Kubernetes resource structure. If you want to pass environment configurations between two different applications, you have to set up secrets or config maps to do so. If you want to claim persistent volume claims is the object kind to define in the Kubernetes API. Similarly, for load balancing, you have services. For security, you can define network policies, so on and so forth. And the beauty of all of this is you have to define this once. Once you have defined that, you can point that Kubernetes API to a cluster that's running on AWS, it will still work. You can point that to a Kubernetes cluster running on Google Cloud, it would still work. So it's a declarative nature. You don't have to define different policies for different cloud providers. So let's get into a demo. So for my demo, I have a polling application that has 3 specific components. So for example, there is the front end, which is a React-based front end that is going to serve as a way to create a poll, and somebody can log in and create a poll in that particular app. The front end, of course, talks to a Spring Boot app server in the back end. The Spring Boot app server has some REST-based services defined. And to store data, the Spring Boot app server needs to talk to MySQL server, right? So that is, the overall architecture of our application. Now, if you think about it, when I want to even build or deploy this application, I'll have to do a couple of things. So for the first component, which is the React-based UI, I'll have to define my deployment requirements, how much CPU memory and things like that. The second requirement I'll have to, inject is where is the Spring Boot server? Where is the app server? Because if I get a request on my front end, that's the server I'm going to pass on the request to. And then, of course, how do I access it? Similarly, for the application server or the second component, you want to have it talk to, or you want to define resources for that, and then you want to define how do I access the MySQL server, what are the username parameters, and you need to inject this at runtime. So if you are using certain parameters during build, you cannot use them, again, during production or during another deployment, because those values might change. So you'll have to figure out how to do that. And again, for the MySQL server itself, you need certain persistent volumes, and then who has the access to access a database within that server. Now, what that converts to in the Kubernetes land, like I explained in the slide before, is for deployments for each of these components, we'll have to define a pod or a deployment spec. For the environment variables that we need to pass, for example, the SQL Server database, passwords and things like that, we'll have to create secrets and config maps. And then for each of the service, we'll have to create a service type so that when the pods are deployed, they get an IP address. That way they can communicate with each other. So for the MySQL server, also I'm going to define a volume claim so that we can get some persistent data in there. So that's the overall requirements for that application to be ported to Kubernetes. The flow I'm going to go through next is pretty much the same for all those 3 components. We're going to write code, we're going to build that code, we're going to put our application executable into a Docker file, push it to Docker Hub, and then we're going to define our requirements for Kubernetes through a bunch of YAML files, and then finally push that to Kubernetes. So let's get into the demo. So what I have here is the app server. You can see this is a very rudimentary application that is just going to take requests and pass it to database. It has, if you look at the application properties file, it does have certain database JDBC connections mentioned and certain username and passwords defined. I've already built this, so I've got my jar file created through Maven. Now, I already have that file. I need to put that in a Docker container so I can port that to Kubernetes. And I'll have to define my Docker file for that. So here's my Docker file for that. Now, if you look at it, what I'm going to do is I'm copying my source files, my Java files, into a container that is going to be based on OpenJDK. Yeah.
Are you sharing your IDE? Because we're not able to see it. We're still only seeing the slides.
Okay, sorry. Let me share my whole desktop. Can you see it now?
Yes, thank you.
Cool. All right, so again, I'll just go back, rewind last minute. So this is the application server app that I have. there are certain, it needs to talk to SQL Server. So we do have this particular JDBC URL requirement defined within the application properties, along with certain other things like how to talk to SQL and what are the username, passwords, and things like that. I've already done a build for this, so I do have the jar file created. What I'm going to do is push this jar and all the build artifacts into a Docker container. Here's my Docker file. I'm going to base it on OpenJDK. You could pick whatever you want, but ideally you should have a very small container footprint. And then I'm going to push my source and app and build files and materials into that container and build it live there. And once the container is done booting up, we're going to run the Java. So the last entry point that you see over here is basically running that application through Java within that container when it gets ported. Similarly, I have another, let's see if I can do this. Similarly, I have the client application also defined. This is again a React-based application. I have a Docker file for this, which is going to be based on Alpine Linux 12.4. And I'm going to dump my React files and everything, do a live build using NPM over there within the container itself. And then finally, I'm going to start my app. So these two are the Docker files needed for each, the app server and the UI server. Now, one interesting thing over here to watch out for is that for the application server, the MySQL JDBC connection that we provided was what MySQL was available during build time, and we'll have to replace it with something or pass live SQL Server connections when that particular container gets deployed. So let's see how we can do that. So I'm going to jump context a little bit and get into the Kubernetes land. I'm using VS Code because writing YAMLs is a lot simpler with a VS Code YAML plugin. So here are my deployment files for that. So this is the MySQL deployment. Again, I'm creating a persistent volume type that is of 250 megabytes. I'm going to claim that persistent volume, and then I'm also going to create a service so that the SQL Server can talk to other apps like the app server and the UI server. And then I'm going to declare, what image to use for that particular deployment. So I'm going to call it MySQL. I'm going to pull the MySQL official image from Docker Hub. And then we are defining certain environment parameters over here that we can pass through Kubernetes secrets. So for example, you can create a secrets within Kubernetes that has your database username, your database password encoded in 64-bit encryption. And what happens is when Docker builds, when Kubernetes is going to deploy, it's going to pull the application or pull the container MySQL 5.6. It will then automatically inject all these different environment variables within the container. So, the application running has access to those environment variables. Now, that was my SQL server. Let's get to the app server. So here's the app server again. So for the app server, I'm going to call it the polling app server. I've already built my container and pushed it to my repo, and that's what I'm going to use to pull. I'm defining certain specs, like because this is the interesting part, because this app server needs to understand how to talk to my SQL server. I'm going to create an environment variable where it's going to fetch these exact parameters from the secrets that we created. So it's the same secret file, same secret definition within Kubernetes, but both the SQL server and the app server are going to share that. So that way it's consistent, and that's how we're going to pass environment configurations into each other. Similarly, with my application or the UI container, this is the standard Kubernetes YAML file for that. I'm creating a deployment. I'm going to create a service at port 80, and that's how I'm going to connect to that server. So let me show you, I want to be sure I have some time. Okay. So let me show you the Kubernetes that I have right now. Okay. So I'm using Octant, which is again an open source tool to kind of, it gives you a view of the Kubernetes dashboard. And I'm using that. You can run it from your laptop. So currently there are no deployments, there is no jobs, there are no pods. My Kubernetes cluster is running in AWS and I'm using tons of mission control to deploy that and connect to it. So one thing before I start, I've already created certain secrets within my Kubernetes environments, the 3 secrets that I want to pass between my SQL Server and my application server. So the MySQL database URL, the password, and the username. You can create this simply either coming into the dashboard or creating these, or you can even define them in your YAML files. Just don't upload them your GitHub repo or something like that. So these are base64 encoded. You won't be able to actually see them. But when the container comes up, they are mounted to a mount point in the container file system, and they can read all these different values from within the container. Okay, so let me get into this and start deploying. Hope my font size is okay. So I'm going to first deploy my SQL Server because I want it to be up before my app and UI servers come up. So I'm going to just do that. So this is going to create the persistent volume, the service, and the actual application deployed within SQL Server. So let's take a look at the dashboard again. So now you'll see, the polling app, MySQL Server pod has been deployed. If we look at the pod, you'll see that there are environment variables that we've passed through the YAML file and through the secrets. They've already been injected into its environment variables. So it has all these, all this key value pairs already within its container. Next, I'm going to deploy the application server. This only will have the deployment and service because it's just an app server. I don't necessarily need a persistent volume for that. So if we go to our pods, you'll start seeing that now we have the app server and MySQL server. Also, we created services for both these through the same YAML file. So you'll see that the app server is running at a particular IP address for a specific port. So for example, SQL Server is at 3306 and the app server is at 880. I'm going to load the front end. Again, just a deployment and service for this workload as well. So if I go back to pods, you'll see that all 3 containers are up and running in the pods. There are 3 services created. And if I get into the client app server, there is no secrets being shared because we didn't define them. And so the secret is only available to the pod SQL server and the app server. Now, I've already created services for these. So, let's get into the actual container and check out how our Spring Boot app is working. So let's get into the server. YAML summary. I can even do this, sorry. Get into the polling server and I can just execute a command. I can say, so you get that. Oh, there's no bin bash, so that's why it failed. But typically, if you want to check out the logs, or if you want to see how your app server is doing, you'll probably see logs, or another way to do that is kubectl logs. Let's see, let's get the pods. So I can do kubectl logs for my polling app server over here. And there it shows like, all the things that are happening, Java is booting up, Spring is starting, all the things, dependency is starting, the different beans loading up and things like that. So that's one way to figure out. Now, what I've also done is I've actually created a public load balancing IP address. Again, this is a very simple thing to do. If you look at the polling app client server, what I've done is I've just mentioned within the service deployment, I want to expose that application using a load balancer type at this particular port. That's all I did. And what Kubernetes did is in the backend, because I'm running on AWS, it went ahead and created an Elastic Load Balancer, and it gave it an URL through which I can access my application at that particular port. So it's as simple as that. Just define your service requirements, and Kubernetes is going to make it happen. So if I go to this particular URL, I should see that application up and running. Yeah, that's the polling app right there. So I think that's all I had for demo. If there are any questions, I can help answer.